All right. So yesterday we talked about frequency graphs, have numbers on it, and tally charts. Today we're going to talk about picture graphs. So a picture graph uses small pictures or symbols to show and compare information. Nick has a picture graph that shows how some students get to school. How many students ride the bus? So first off, underline the word that tells you where to find the information to the question. So we're going to have to underline this. Nick has a picture graph because this is where the information is. It's showing us how some kids get to school. So underline that. And it says up here, how many smiley faces are shown for bus, Caleb? Eight. Correct. So write 8 up here. And make sure we got to write quick. Wait. We're recording. We got to write fast and we cannot lag behind. I don't want to do a lot of videos. So each row has a label that names one way the students get to school. Look, we have 3 smiley faces for walk, 4 for bike, 8 for bus, and 6 for car. The title of the picture graph shows how the students get to school, and the key, this is the biggest part, key. The key tells us each picture symbol stands for the way of 10 students. So, for example, Troy, is this 3 students? Are you sure? Each smiley face stands for 10 students. It means it's 30, right? So what would this be, Troy? 40. And I'm decoding it. What would this be, Troy? Uh-huh. And what would the last one be? Yes. Good. That key tells us all. And what you did, Troy, you just multiplied. So let's do our pattern. To find the number of each student to ride the bus, count each smiley face as 10. So it would just be 10, 20, 30, 40, 50, 60, 70, and 80. Just like that. And we already figured out, we know that 80 students ride the bus to school. That's multiplication. You just multiplied, Troy, 10 times 3, 10 times 8, 10 times 6, and 10 times 4. That's good, Troy. Real good. Does that make sense, David?
Yeah.
That makes sense, Adelie?
Kenna? I put 80 because I saw the.
Okay. Caleb?
At the top, when we
Makes
put
sense.
8, I put 80. Kinda. Because that is how many students.
All right, we got to move on. How many fewer students walk than ride the bus? So let's look up here. How many students walk and how many students ride the bus, right? So we have 80 students that ride the bus. And how many students walk? Go ahead. So what's 80 minus 30, Caleb? 50. Now, the next one says how many students were surveyed, which means how many students participated. We have to add these up. Let's see if we can mental math this, Willow. Let's add 60 plus 40. What does that equal? Willow. What's 100 plus 80 equal? What's 180 plus 30 equal? 210. Good. Great. 210. What if instead of it showing 10 for each student, what if the symbols stand for 5 students? How many symbols will you need to show the number of students who walk to school? So let's say, here's walk. Wait. And let's say it still has to equal 30, right? But now this is 5, this is 5, and this is 5. What's 5, 5, and 5, Jack? So how many more would I need to make 30? What? I would need 15, but how many smiley faces would that be? 3. We would need 3 more smiley faces. Don't worry about writing this. So what would give us a total of how many smiley faces, Jack? Nope. Smiley faces. Six. So write 6 right here. Great. That's a good first page for us. We got through that, no problem. Adeline. They use half symbols, okay? So how many students chose an orange as their favorite fruit? So an idea, if a full circle, a full smiley face is going to be 2 students, a half is obviously going to be 1, because what's half of 2, Adeline? So let's say it was, let's say the smiley face equaled 10 students. What's half of 10? Half of 10. If you take 10 and cut it in half, what do you have? Adeline? 5. So Adeline, let's say they had 20 for each smiley face. What's half of 20? Let's say Adeline, they had 100. Code our graph. I always like doing that. McKenna, how many students like banana? If each smiley face stands for 2 students. 10. Caleb, how many students like apple? 6. Cortland, how many students like pear? I'm sorry? Pay attention. 4. Troy, how many students liked orange? Not 8. You're close. 9. Yes, because look, 2, 4, 6, 8, and that stands for 1, so it's 9. Good. So we know this is, if I count the number of smiley faces, it'll be 2, 4, 6, and 8 because we'll skip counting 2s. And it wants to know how many students chose orange as their favorite fruit. Well, we know we have 8, and then we have the half, which stands for 1, and we know 8 plus 1 is 9. So 9 students chose orange as their favorite fruit. I'll give you guys 30 seconds to write this. Yeah, it shouldn't take anyone that long. Courtney, you getting it? Okay, thank you. Good. We're flying through this, which is great. So we're using this chart for this page. Willow, what does the book stand for? What does each book, or what does half a book stand for? One book, yes. Because look, a full book has 2 pages. A half a book stands for 1 book. Not 2 books, because a 2 of them, 1 full book stands for 2. Caleb, how many books? Hold on. How many books did the students read in September, Caleb? Let's go ahead and decode our graph before we do anything. So first off, Caleb, how many students did read in September? 7, yes. Yeah. How many students did for October? And November? Good. Go ahead and do number 2 and 3 real quick while I talk to Mr. Jerry. 2 and 3 real quick. Keep it real easy. And label. You're welcome. All right. McKenna, how many books did the students read in September? We should know this. How many? 7 books. And Jack, how many more books did the students read in October than November? 4 books. Because you did 12 minus 8. Great. Did everybody get that? Oh, hold on. This one is on your own, but I'm going to do it with you. Let's decode our graph real quick. Each puzzle piece stands for 4 students. So, David, how many students liked puzzles? How many students liked, what is a half of a chess piece going to be? Okay. So, David, how many played card games? Okay. And how many played board games? So, David, you just multiplied. You did 4 times 5, 4 times 3.5, and 4 times 6. It's great. So, David, how many students chose puzzles? 20 what? Huh? 20 puzzles chose students? 20 what again? You got it. There's 20 students. Or I'm cool with that if you're cool with it. Adeline, if 6 more students voted for card games and 4 more students voted for board games, let me write this down. This is a go deeper question. So this one's gonna be tough. I want everyone to think about it too. And 4 more students voted for board games. How many more students voted for puzzles and card games than board games? So, first off, let's add to card games. So, Adeline, what's 14 plus 6? So I'm gonna put 20 right here. And 4 more for board games. So what's 24 plus 4? Right? how many more students voted for puzzles and card games than board games. So now we're going to have to add puzzles plus card games and then subtract it. So, Adeline, what's 20 plus 20? And now we're going to subtract it from board games, which is 28. Adeline, 0 minus 8 is? Huh? There's something on my floor. It's a little bit more. So I might have to go visit next door. I'm about to borrow from next door. So Caleb, the 4 becomes a, wait. This should be good. 4 becomes a 3. Three minus 2 is 1. So 12 what? How many more students? That's a tough question. Those are the go deeper questions. Those are ones where see if you can connect the puzzle pieces together. Make sure you write all this. What? No, connect a puzzle in your brain. A puzzle in your brain. There's another go deeper. One go deeper always is makes me even think. They're good questions, and if we can figure those out, then we know we're doing it right, and we just figured that out pretty well. I like this lesson. This lesson you guys are gonna fly through. This is easier than last chapter, isn't it? This is easier than last chapter, isn't it? All right, I'm gonna scroll down. So, which 2 types of games did a total of 34 students choose? So let's erase this. Cortland, let's see if you can get this one. If I add 2 of these up and it equals 34, what's 2 am I going to add up? That makes 44, so that's a little bit too much. Wait. 14 and? Good. So what has 14? What game? And what has 20? There you go. Card games and puzzle. Great, Cortland. Great. The last one is a go deeper question. How many students were surveyed? I want you to try to figure that one out. We're surveyed. You have to do something. And if you think you got it, raise your hand. What's wrong with that one? Wow. What?
No, well, right.
I don't know. You tell me. How many students were surveyed? We just talked about surveyed students on the page before this. Survey. If you think you have an answer, raise your hand. If you think you have an answer, raise your hand. Troy, you gotta try. How many students were surveyed? All right, Caleb has got it. What is the answer, Caleb? 58. How did you find 58? Yes, you added all 3 together and you got 58. 58 what? Look right after how many, always. Yes. Now figure out this. We have 58 students. How many students did not choose card games? So let's take 58 and minus it by card games, right? Troy, 8 minus 4. Five minus 1. 44 what? Great, Troy. Great. You guys are all firing on all cylinders today. Correct, without hesitation. Good. Jack, be quick. All right, Jack. Jacob said one more student chose board games than puzzles. Explain his error. So he said one more student chose board games than puzzles. Explain his error. It's really 4 students, but what did he think? Why would he think that one more student chose board game over puzzle pieces? Why would he think that?
I think I know.
Wait. Jack's brain's firing. Look up here on the board. Look up on the board. He's thinking one more student. Which is? One less what? There's one less what? Chess piece? On board games or puzzle pieces? Right. So what he thought was, check this out. 1, 2, 3, 4, 5, 6, and 5. So he said, oh no, there's only one more student likes board games and puzzle pieces, but that's not the case because he didn't look at his key. We know one piece is 4 students. So Jacob's error, he did not look at the key. He did not. And it's computer games. I'm going to put CG for computer games. And remember, 4, 8, 12, 16, 20, 4, 8, 12, 14, and 24. So it has to be more than puzzles, but less than board games. What number is between 20 and 24? 22. How would I get 22? How many would I have to draw? Let's skip count. 1, which is 4. I need a half. 8, 12, 16, 20. And instead of putting another one to make 24, I would do just a half, which would make, so we need 1, 2. I'll try to do a right triangle, but it's hard on this. It's supposed to be like this. So it's 4, 8, 12, 16, 20, 22. So how many students would choose? It would just be 22. You don't have to do all that. You don't have to. I've made it up there. You don't have to make it on your paper. Just write the answer in.
So it's not like your problem. It's my problem too.
All right, number 11. We're going to use this favorite camp activity. What does each sun stand for, Cortland? So what would a half a sun stand for? Hold on. We need. Oh, wait till after this. Yeah, you're right. So Cortland. Okay. We'll figure something out. So Cortland, how many students went biking? If the sun stands for 6 and a half stands for 3. Actually, anybody try to figure that out. That's a big one. Who thinks they can figure out this chart? Caleb, how many students went biking? Yeah. Willow, you work on hiking.
12 and then 12 minus.
Wait, Minison?
No, but I'm just saying 12 and then minus 6.
Not 6.
Minus, take, it'll be like a 6 and then take 3 away.
So 12 plus 12 minus 3. 21. You were right. All right, Phil. Wait, David, Willow. How many students went hiking? David, how many students went boating? And Adelie, how many students went fishing? Huh? 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 What does half a sun equal? What's half of 6? Huh? Half of 6. 3. So what's 6 plus 3? 9. See, look, Adelie, this sun stands for 6, and half of 6 makes 3. 6 plus 3 is 9. So the students who went to summer camp voted for their favorite activity. Which 2 activities received a total of 39 votes? First off, what do we need to find? Which equals 39. What steps will we use to solve the problem? We will solve the graph. Which we already did. Then add. We're going to solve the graph, then add. We don't know what we're going to add yet, but we know we're going to have to add. So, all right. Right, David. Right, McKenna. So the steps we're going to have to do, guess what? We've kind of already did it by doing this, making your frequency chart. So all I'm going to do is write biking equals how much? 21. Hiking equals 24. Boat equals 18. Make sure you're writing this, guys. And fishing equals 9. Fishing equals 9. Make sure you write that.
I'm not done with the A. On top of solid graph, then do you have your boating license?
So we can complete number D. Willow, what does a sun equal? And what does a half a sun equal? 3. So biking plus hiking, what does that equal, Willow? 21 plus 24, do mental math. What's 4 plus 1? 2 plus 2? So 45. Now hiking plus boating, we cannot do that way because we have to borrow. So we got to do it like this. 24 plus 18. Troy, 8 plus 4 is? 2, carry your 1. 1 plus 2 is? Troy? Plus 1? 42. Biking plus boating. Jack, do mental math. 1 plus 8 is? And 2 plus 1 is? So look, 39. And lastly, fishing and hiking. We can't do it the old way because you got to borrow. So 24 plus 9. McKenna, 9 plus 4? 3, carry your 1. 1 plus 2? 33. So Adeline, which one of these got 39 votes? Right. Biking and boating. Biking and boating. Make sure you guys get that copy down. Biking and boating. And if you finish that, go on to your practice homework. I'm going to stop the recording and then we'll talk about it. Oh, estimate, guys. We have to round on these two. And we have to round on all 4 of these. All right, let me stop this recording. 34 minutes.